right, calculus. Calculus, there's a couple of questions I need to go over for homework. I hope I go over the right ones. I have some people going, can you go over this from this section and that from that section? So I think I have it straight. So I think what I'm doing is I'm doing 3A and E from the vertical asymptotes section, so page 347. And then I'm doing 5A and F from the horizontal asymptotes section. I hope I have that right. If I screw it up, just let me know and I'll fix it. All right. So, section 6.4, page 347, 348. I'm doing 3A and E. So 3A and E. Okay, just a second. Oh, thought I already did 3A. Maybe I did. Maybe I didn't. I don't remember. I've done too many things. Okay, so 3, it just says find each limit, and it says find the limit as x approaches 5 for 1 over x minus 5 squared. So we can't put 5 in there. I'm looking for Harriet, sorry. We can't put 5 in there as a value because 5 take away 5 will put 0 on the bottom of a fraction, and we can't have that. Sorry, that's Wicket. He's got a leash on and he's headed downstairs. So what I can do is I can choose, because it doesn't say the right-handed limit or the left-handed limit. It just says the limit overall. Hello, Autumn. Autumn wants to say hi. Hold on. Autumn's visiting. Autumn wanted to say hi. I don't know why, but she came running upstairs. Hello. Yes. Hi. 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 Say hi. You should I say hi? Okay. Say bye. I gotta teach. Okay. So, bye, Autumn. Sorry about that. Yeah, I'm not really sorry. So, because they want the limit overall for 5, I'm going to check something on the left-hand side of 5, and I'm going to check something on the right-hand side of 5. So if I do 4.9 minus 5, that's negative 0.1. But if I do negative 0.1 squared, that actually gives me positive 0.01. And if I do 1 divided by positive 0.01, I get 100. So that's a relatively large number. If I do 5.1 minus 5, that's 0.1. If I square it, that's 0.01. And I do 1 divided by 0.01, that's also 100. If you did this, if you did 4.9 minus 5 and you got negative 0.1, and all you did in your calculator was hit squared, it might tell you negative 0.01, but your calculator's lying to you because you lied to it. If you put a squared on here and you didn't have brackets there, what happens is your calculator does 0.1 squared and then it puts the negative on, and you don't want it to do that. So if that is your problem, if that's what happened to you, that's why. You have to make sure that your calculator squares not only the 0.1 but also the negative. All right, so because they're both approaching a large number, my limit is infinity. 3e says x squared plus 4 over x minus 2 squared, and it's the limit as x approaches 2. So again, I can't make 2, but I could do 1.9 and I could do 2.1. So this one's a little bit more complicated simply because I can't cancel anything here, and I've got this yucky thing on the top, but I can still do it. I can handle it. If I do 1.9 squared plus 4, on the top I have 7.61. If I do 1.9 minus 2 squared, whoops, sorry, sorry, 2.1 minus 2, or sorry, 1.9 minus 2 squared, I get 0.01. Now, if I do 7.61 and I divide it by 0.01, I get 761. I get a really big number. If I do the other side, if I do 2.1 squared plus 4, 2.1 squared plus 4, I get 8.41. And on the bottom, 2.1 minus 2 is 0.1, squared is 0.01. And so when I divide them, I get 841. So again, either side I'm getting a very large number, so that means it's also infinity. Okay? My husband's home and I can hear him downstairs cleaning up after me. I'm such a slob. All right, that is that section. I think those were the only additional questions that I had not answered in a previous video for that section. Not everyone has finished horizontal asymptotes yet, and I get you have until the end of today to do it, but at least one person had already done it and said, can you do these questions? So that's great because it gives me a chance to kind of fit those in early. So 5A and F were the questions that were asked on page 360. So it says, find the equation of the horizontal asymptote for each of these curves. So if it's a horizontal asymptote, no matter where it is, let's just say it's here, okay? It's going to be y is equal to something because it's all along the x, right? It's got all the x values to it, but it's at a very specific height. So if this was at 2, the equation would be y is 2. So we just need to figure out where would it be. It doesn't ask us to draw anything, thankfully. So for 5a, it has 2x minus 3 over 5 minus x. Now, I'm not really happy with the way that's written because I like it when my x's line up with each other and my constants line up with each other. So I'm actually going to take that negative x and put it here and the plus 5 and put it here. No reason other than aesthetically, I like it better that way. I don't know, I'm crazy. Now, one of the things I said in the last video was that if the degree on the top is the same as the degree on the bottom, and it is, take the leading coefficients. So 2 and negative 1. So 2 over negative 1 would be negative 2. So the equation of the horizontal asymptote would be y is negative 2. So if I were drawing this, I would be putting the horizontal asymptote here at negative 2. But it didn't ask me to do that, but hey, I'm a full service teacher. F, 6x squared plus 4x plus 1 over 5 minus 3x squared. Again, not a fan of how that's written. I would write it just to make it easier on my head, negative 3x squared plus 5 is how I would write it, because the squared is now over the squared. The degree is the same, so I take the leading coefficients. So 6 over negative 3. Again, the equation of the asymptote would be y is negative 2. All right? So that's it for going over homework. Again, if you did not finish the horizontal asymptote section yet and you do end up with questions, that's no problem. I'll just stick them into the next video. So we had done the first part of section 6.5, which dealt with horizontal asymptotes. And up to this point in math, you've already looked at vertical asymptotes before, not new. You've already looked at horizontal asymptotes before, not new. There is another type of asymptote. We don't see it very often, to be honest, and it's something called an oblique asymptote. I won't be asking you to do very much in-depth drawing with an oblique asymptote. I will mostly just be asking you to find the equation of an oblique asymptote. I might even ask you to put the oblique asymptote on the graph, but then I won't be asking you to do a whole lot of the surrounding work with it. So I'm actually looking at example 4 on page 356. So an oblique asymptote, what it does is it goes in some way diagonally through your graph. It might go exactly diagonally through your graph. Could do that. Or it could go somewhere else diagonally. Maybe it'll go like this. Okay? Because it is a diagonal line, it's not just going to be x is equal to 3 or y is equal to -2 like we just did. It's actually going to have an equation in the form of y is equal to mx plus b, so that it has a slope and it has where the y-intercept is. So it's actually going to be an equation. Now, how do I know if there's an oblique asymptote, and how do I figure out what that is? So let's talk about those two things as we do example number 4. Example number 4a, there's part A and part B. Example number 4a says, find an equation of the linear oblique asymptote for each curve. Now, it only says find the equation. It doesn't ask you to draw anything, and it doesn't ask you about any other asymptotes. And then when they go and do the solution, they draw it for you. I don't know why, but they do. I guess just so you can kind of connect everything. So the equation that they give you is y is equal to 2x cubed minus x squared plus 3 all over x squared. Now, because there is a denominator, I know there's a vertical asymptote. It didn't ask me about this, but I'm going to talk about it anyway because I want you to be connecting everything together. So I do know that there's a vertical asymptote because there is a variable in the denominator. Now, what would x have to be to make the denominator 0? And I hope you're saying 0. So there is a vertical asymptote where x is 0. So right here, there would be a vertical asymptote. But when we talked about horizontal asymptote, we said there is a horizontal asymptote at 0 if the degree of the denominator is bigger than the degree of the numerator. But it's not. In this case, it's the reverse. In this case, the numerator is bigger than the denominator. Just because the degree of the numerator is bigger than the denominator does not necessarily mean there's an oblique asymptote, okay? So we know there's a horizontal asymptote if the degree on the bottom is bigger than the degree on the top. We know there's a horizontal asymptote if the degrees are the same, because then we just take the leading coefficients. Now, if the degree of the numerator is bigger than the denominator, or if you want to think of that the other way, if the denominator is smaller than the numerator, I don't care which way you think about it, if the bottom is smaller than the top, there is no horizontal asymptote at all. There may or may not be an oblique asymptote, and here's how you tell. If the degree of the top is 1 more than the degree on the bottom. So the highest degree up here is 3. The degree on the bottom is 2. The top is exactly just 1 more than the bottom. So there is an oblique asymptote. All right? But how do I know what that is? Here's how you know what that is. You divide the bottom into the top. You divide the bottom into the top. Now, if the bottom is just something like x squared, that's not so hard to do. Let me show you. If 2x cubed minus x squared plus 3 is all divided by x squared, that means I could write it this way. 2x cubed is divided by x squared. That piece is divided by x squared. The x squared is divided by x squared. And the 3 is divided by x squared. Each piece has the x squared as a denominator. So I'm going to look at each piece separately. With this piece, x cubed over x squared, remember you subtract your exponents when you're dividing, so this would actually be 2x. Here, x squared over x squared, it's the same thing over the same thing, right? So that's just 1. Anything divided by itself is 1. Now, if you have a constant over this, you just get to ignore it. It's counted as 0, okay? It's just counted as 0. Because again, if that x was infinitely large, 3 divided by 1,000 is going to be a really small number. So we just ignore that entirely. Notice what I have left is a nice little linear equation. This is the oblique asymptote. So if I was going to put this on the graph, the y-intercept is -1, so down 1, and the slope is 2, so up 2 over 1. And so my linear asymptote, my oblique asymptote would look like this. That's really about all I would ask you to do in terms of drawing it. However, they go ahead and they do like a table of values to figure out what it would look like. Turns out, as it approaches the vertical asymptote on the left-hand side, it gets infinitely large. And then because there's no horizontal asymptote, it can cross and keep coming down, but again, it can't cross that oblique asymptote, so it just starts kind of going off. And then it turns out it's not over here at all. It doesn't exist over here at all. It just doesn't work. Turns out on the right-hand side, as it approaches the vertical asymptote, it does that. And then it heads downward, but again, it can't cross that asymptote. So instead what it does is it kind of gets deflected off of it and deflects up that way. I'm not going to expect you to be able to do that. That's not my expectation at this level. All right? All right, but life gets a little bit less fun. Life gets a little bit less fun with the next one. So this is example 4b. In example 4b, this is probably bothering some of you. Here we go. It says y is equal to 2x squared minus 7x minus 2 all over, and again, they make it 2 minus x. I'm going to make it negative x plus 2 just because I like it better. You still, to find the oblique, okay, so let me back it up just a little bit, sorry. Again, there would be a vertical asymptote when x is 2, because if I make x 2, then I would have negative 2 plus 2, which would put 0 on the bottom of the fraction. So at 2, there would be a vertical asymptote. There is no horizontal asymptote because the degree on the bottom is 1, the degree on the top is 2. So the top is bigger than the bottom, so no horizontal asymptote. But because the degree on the top is exactly one more than the degree on the bottom, that means there is an oblique asymptote. But because what's on the bottom is a binomial, it's not as simple as the last one. You actually either have to do long division here, or you can do synthetic division. That word should ring a bell somewhere in your mind. We have done synthetic division in grade 11, and I think we might have come across it in grade 12 as well. I'm trying to think, but I can't remember. So in the textbook, they actually do long division. So they do negative x plus 2 into 2x squared minus 7x minus 2. And they do, here's the thought process, right? So let me jog your memory on long division. If I said do 3 into, I don't know, 962, you would go 3 goes into 9 3 times. 3 times 3 is 9, and 9 take away 9 is 0, and you'd move down your 6. So now you have the number 6 there. 3 goes into 6 2 times. 2 times 3 is 6. 6 take away 6 is 0. Move down the 2. 3 goes into 2 0 times. And so 0 times 3 is 0. And so I have nothing left to bring down. So my remainder is 2. And the answer is 320 with 2 left over. Same process here. Just a little bit yuckier. So I would say, how do I turn negative x into positive 2x squared? And the answer is, I would multiply it by negative 2x by negative 2x. So if I do negative 2x and I multiply it with what's out here, negative x plus 2, I would end up with 2x squared minus 4x. So I'm going to put that here, 2x squared minus 4x. I would subtract this. So I have 2x squared, take away 2x squared, so that's gone. And I have negative 7x, take away negative 4x, which would be negative 3x, and I would move down my negative 2. And then I would say, how do I turn negative x into negative 3x? And the answer is I would multiply it by positive 3. So I would take this positive 3 and I would multiply it with what's out here. So this would be negative 3x plus 6. And so I would subtract those. So this take away that would be 0. Negative 2 take away 6 would be negative 8. There's nothing else to bring down. So my oblique asymptote would be negative 2x plus 3, and there would be a remainder, but the remainder doesn't matter. We just ignore it. So I would put my asymptote, my y-intercept is 3, 1, 2, 3. My slope is negative 2 over 1, so I would go down 2 and across 1. So 1, 2, and across 1. And so this would be my oblique asymptote. Now, if you don't like long division, that's okay. Synthetic division. Let me jog your memory on synthetic division. Synthetic division, what we do is we ask ourselves, what would x have to be to make this bottom 0? And the answer is 2. So we put 2 out here, and across here we put 2, negative 7, and negative 2. We bring down the 2, and then we multiply. 2 times 2 is 4, and we add negative 7 plus 4 is negative 3, and negative 3, multiply it with 2, is negative 6, and negative 2 plus negative 6 is negative 8. Whatever the last thing is, that's your remainder, and you ignore it. This is the constant, this is x. I got the same, I didn't get the same answer. What did I do differently? That should be 2. I got my signs messed up somehow. negative x plus 2. Oh, you have to flip the sign. You have to flip the sign. If 2 is what would make it 0, then you put negative 2 in there. You have to flip the sign. I can't remember why that is. So that would make negative 2x plus 3, which would give you what you wanted. So it's the opposite sign. So if 2 will make that 0, then you put negative 2 here. I don't know why that is. I don't remember. All right. So let's look. And again, I wouldn't ask you to do anything other than put the asymptotes where they go. They do finish it. They say on this side of the vertical asymptote, the limit is infinity, so it's going up, and then as it heads down, it doesn't cross that. They say on the other side, what actually happens is it's nothing in here at all, and it does this and comes down here. So there are ways to figure that out. At this level, you don't really need to know how to do that. Although if you figure out what's happening on either side of your vertical asymptote, you really can just fill the rest in. It will follow. So number 5, find all the asymptotes and use this information to sketch the curve. So I'm going to show you how you would sketch a curve. I'm not going to ask you to do anything super complicated with it. All right? So x squared minus x minus 2 over x minus 1. So again, there would be a vertical asymptote where x is 1, because 1 take away 1 would give you 0. So where x is 1, there is a vertical asymptote. There's no horizontal asymptote, but because the degree on the top is 1 bigger than the bottom, that means there is an oblique asymptote. To figure out the oblique asymptote, you either have to do long division, or you can do synthetic division. So let me just try this. So 1 take away 1 would give me 0, so I'm going to put negative 1 out here. I'm going to do 1, negative 1, negative 2. So I move my 1 down. I go 1 times negative 1 is negative 1. Negative 1 plus negative 1 is negative 2. And negative 2, that's 2, and that's 0. And so I end up with x minus 2, but that's not right. All right, what if I ignore what I told you the last time? The last one was kind of wonky to do synthetic division with because of the fact that they put the negative on the x. So if I just put 1 out here, let me try that. 1, negative 1, negative 2. If I move the 1 down, 1 times 1 is 1. That's 0. 0 times 1 is 0. That's, yeah, this one actually works. So ignore what I said a few minutes ago. I'm sorry. Ignore what I said a few minutes ago. As long as the x is positive, whatever will make it 0. So 1 take away 1 would be 0, so I'm putting a 1 out there. All right? What was wonky about the last one was the fact that there was a negative out there. It really messed everything up. They did it by long division. It's the safest route. I just find it difficult to do. So this is my remainder, so I don't use it. This is my constant. This is my x. So y is equal to x is my, or if you want, x plus 0, if that makes you happier. That is my oblique asymptote equation. So my y-intercept is at 0, and my slope is 1 over 1. So up 1, over 1. So here is my oblique asymptote. Now drawing these, even though they look kind of complicated when I was drawing them really isn't as complicated as it seems. This would be one that would be easier to do than maybe the first one that they did. What you really should do is what we did when we were doing vertical asymptotes, and they asked you just to graph what was happening near the vertical asymptote. So what I'm actually going to do is I'm going to do a quick table of values, and I'm going to pick something on just on this side of the vertical asymptote and something just on that side of the vertical asymptote. So I'm going to pick, say, 1.9 and 0.9, my apologies, and 1.1. So something on the left-hand side of 1, something on the right-hand side of 1. So if I make my x 0.9, and this is the equation, y is equal to this is just the equation for my asymptote. This is the actual equation for graphing. If I put 0.9 in there, what did I do with Harriet? There she is. If I put 0.9 in there, 0.9 squared minus 0.9 minus 2 on top gives me negative 2.09, and 0.9 minus 1 gives me negative 0.1. So if I divide by negative 0.1, I get 20.9. I get a very large number. So close to the left-hand side of the asymptote, the graph is going up. It's increasing. There's no horizontal asymptote, so there's no reason why it can't just go down. So again, we're just doing a sketch, so it doesn't have to be like every point is where it needs to be. We can just do, it's going to come down. I don't know how much of a curve, but when it gets close to this asymptote, it can't cross it, so it's just going to kind of go off to the side of it. You could find intercepts to be a little bit more accurate, and what I mean by that is you could find an intercept by making your x, but on a table of values, making your x 0. If you did, you would have negative 2 over negative 1, which would be 2. So it should be, there's a point at 0 and 2. Well, I kind of have that there. The other option is to make your y 0. And again, this is just to try and be a little bit more accurate in your drawing. It's not a big deal. If I made my y 0, I'd have x squared minus x minus 2 over x minus 1. I'd multiply this side by x minus 1 so that they cancel. So I'd multiply this side by x minus 1. So I would have 0 is x squared minus x minus 2. I would go, hey, I think that factors to x minus 2 and x plus 1, which means either x is equal to 2 or x is equal to negative 1. So according to this, if my y is 0, my x could be negative 2, or my x could be, positive 2, or it could be negative 1. So that means it would cross the x-axis here at negative 1 and 0. It would also cross the x-axis over here at 2 and 0. So it gives me a hint about what's happening on that side. So I said, I'm going to check at 0.9. I'm also going to check what is my value at 1.1. I'm going to check just to the other side of this. So if I do 1.1, I would do 1.1 squared, can't find my squared button, minus 1.1 minus 2, so that gives me negative 18.9, and 1.1 minus 1 is 0.1, so I'm going to divide that by 0.1, and I get negative 18.9. So at 1.1, it's negative 18.9, it's way down here, so it's headed downward. So I know it's got to be here, and so as it goes up, it can't cross that oblique asymptote. So let me recap. I knew where my vertical asymptote was because I knew what would make the denominator 0, and that was 1. So I knew my vertical asymptote was. To figure out my oblique asymptote, I divided the bottom into the top, either by long division or by synthetic division. And I got that y is equal to x, so there's that line. So to graph it, I figured out my y value just on the left-hand side of the vertical asymptote and the right-hand side of the vertical asymptote. So I figured out here and here. And then just to be a little bit more accurate, it's not super necessary, but just to be a little bit more accurate, I figured out when my x is 0, what's my y? So I figured out my y-intercept. And when my y is 0, what are my x's or my x? There might only be one. And so that gave me my x-intercepts. Not the end of the world if you didn't find the intercepts. You can still get the general shape without them. But I'm not going to be asking you to do a lot of this graphing. Very, very little, and on a test, just really putting the asymptotes where they go. I'm not so worried about the extra stuff. If you put it in, hey, maybe some bonus points, I don't know. But I'm not really as concerned about those. So I will give you a few to try on oblique asymptotes. Please don't freak out too much about oblique asymptotes. You're not going to see them all that often. And they're not going to be the major part of chapter 6. So I want you to get it. Whoops. Oh, I just scared a dog. I want you to get it, but don't focus in too much on it. Don't freak out too much if it's still a little fuzzy. That's okay. All right. It won't be the major part of this. The next section we're going to do after this is section 6.6, where it's literally taking everything from the previous sections of chapter 6 and putting it all together in like big giant questions. So I will go over that tomorrow, and you will have tomorrow's Thursday. So you're going to have like Thursday, Friday, Saturday, Sunday to do it. I'm going to give you lots of time to be working on it. That doesn't mean I'm giving you a ton of questions. It just means you're going to have lots of time to work on it and kind of make sure that you have that in your brain. If we feel like we would benefit, like if you had some questions you wanted to ask that wasn't like, can you just do number 5, but you had some more general questions that you wanted to ask, we could do a Zoom meeting about that if you felt like that was going to be beneficial for you. If you don't need it, then that's good too. There's a lot to this, so that's why I'm just kind of saying we'll figure this out. So don't worry too much. We will figure this out. So that's it. And yeah, after that, we have optimization problems to do. We still have a bit left to do, and chapter 6 is like the never-ending chapter. And like I said, after that, we don't really have a whole lot to do. We're going to do pieces of chapter 7 and pieces of chapter 8, and that will really be it. So don't panic too much if you think, oh my word, we still have a ton of this book left to do. We really don't, okay? So yeah, that's it. So I'll talk to you again tomorrow. Bye.